Hello all, welcome to Algorithms Made Easy. My name is Rajat and today we will be discussing the question next higher palindromic number using the same set of digits. In this particular problem, we are given a palindromic number n in the form of string. The task is to find the smallest palindromic number greater than n using the same set of digits as in n. In the first example, we are given that we have a digits 35453. The next greater palindromic number than this particular number is 53435. In the second example, it is stated that the number is 33. Since there doesn't exist any palindromic number higher than this particular number, we will output -1. Since the constraints are 1 to 10 raised to power 5, the expected time complexity is n log n and the expected auxiliary space is O of 1. Now let's first discuss what the question is all about and how we can solve it. For now, let's forget about the input and the output. We'll first discuss what is a palindrome. So the given number 35453, when split from the middle, we can see the digits 35 are present in a mirror image at the end of the number as well, which is 53. Since it is an odd length number, there will be a middle digit present. If the number of digits in the number is even, there won't be any middle number and the number will look like this. The digits in the first half of the number will be present in a mirror image for the next half. Coming back to the problem that we have, the answer given for this particular problem is 53435, which is in turn is a palindrome. Now if we turn our attention towards the first half of this particular number, we see that 53 is the next greater number for 35. That means if for a second we forget about rest of the numbers, then we can see that it's all about the first half of a palindromic number. We need to find out what is the next greater number for the first half of the given number. So we are in turn finding the next bigger number using the same digits. This particular example is very short, and since the number of digits for the first half is only 2, it won't be very clear and intuitive to find out the solution. So let's take a bigger number. Over here we have 4 digits on both the sides. We again leave out the other half and just focus our attention on the first half of the number, which is 7298. The next greater number for 7298 using the same digits is 7829, and if we put the mirror image for this particular number at the back of this number, it becomes the answer that we are looking for, which is 7299287. So what we are doing effectively, if we put that into number of steps, we see that we are taking the first half of the string, we are finding the next bigger number for the half, and if the result exists, we return the palindrome of the string, else we return -1. Now, the whole logic revolves around this step 2, wherein we are finding the next bigger number for the half. And we surely will be discussing that in the further slides. So let's move forward. For the input 7298, we need to find the next bigger number. Now, the question that we can ask, does a next bigger number for the given number exist? If not, we have to return -1 straightforward. This particular question can be asked from a different perspective, which is, we can say, is the given number the largest number? If it is not the largest number, then surely we know that there exists a larger number than this particular number using the same set of digits. And that is an important part. We have to use the same set of digits to create the next bigger number. So let's take this particular question. Is the given number the largest number? We are given this particular number, which is 7298, and we are trying to find whether this particular number is the largest number that can be created using the same set of digits. By looking at this number, we know that the largest number that can be created using the same digits is 9872. Now, the question that we need to ask is, what is the pattern this particular number is following? If we see from the start, we see that the value in this particular number are in decreasing order. So with any given set of digits, the largest number will be the number wherein all the values are in decreasing order from the start. Looking at it from a different perspective, if we look at from the end, we see that the values are in increasing order. For a given set of digits, the largest number will be a number if the values are in increasing order from the end. Talking about a bonus concept, similar to the largest number, we can talk about what will be the smallest number. For digits 7 to 98, the smallest number will be 2789. Similar to what we have seen, from the end, the values are in decreasing order. That's the reverse of what we have seen for the largest number. And if we see it from the start, the values are in increasing order. This particular smallest number thing will be useful to us in this particular problem. That's why we are discussing it over here. So reiterating what we have seen, the largest number for a given set of digits will be all values sorted in decreasing order. From the start, it will look like that all values are in decreasing order. From the end, the values will be in increasing order. The concept will be a reverse in case of finding the smallest number. The values will be in decreasing order from the end and increasing order from the start. Now, coming back to the problem that we had, we need to find out whether the next bigger number for the given input exists or not. If the values are in increasing order from the end, it will be the largest number. So what we need to find out whether this particular number follows the same concept or not. If not, then it is not the largest number, and if it is not the largest number, we can find out the largest number. Starting from the last value, we see that 8 is an increasing sequence since it is the only number. We move to the next value. We see that 98 is an increasing sequence. We again move to the next value. Over here, our condition fails since 298 is not in an increasing sequence. So our focus should be on these three values, since the rest of the digits remaining from the start need not to be changed, and there exists a greater number which can be made using these three values. So we will move our focus on these three digits. Using the digits 298, what all values that we can make. So here is the list of the values that we can make which are in increasing order. We start with 289, we have 298, 829, 892, 928 and 982. You see that the smallest value is in increasing order from the start and the largest value is decreasing order from the start. Currently, the value that we are on is 298. The next bigger value is 829. So how do we find out that the next greater number for 298 is 829? Let's split all the digits that we have. We have 2, we have 8, we have 9. Coming to the question of finding the next greater number. The next greater number for 298 will be a number which is greater than 2. In this particular set of digits, the number greater than 2 is 8. So we take out 8 from this set. Now, once we have this particular number 8, the rest of the digits need to make the smallest possible number. And we have seen that the smallest possible number, it's nothing but all digits arranged in an increasing sequence from the start. This means it will be 2, 9. Once we merge these two values, it becomes 829, which is nothing but the next bigger number for 298. This might be confusing. So let's jump to one other example, which is 298542. That's a bigger number, more number of digits, and the concept will be much more clear in this. The number of digits that we have is 2, 9, 8, 5, 4, again a 2. What we were doing is we were finding the next bigger digit than the first digit, which in this case is 4. Now, what we need to do? We need to make the smallest number out of the remaining digits. To make the smallest number out of the remaining digits, we'll keep them in an increasing sequence. So we'll start off with 2. We again put 2. Then comes 5. Then comes 8. Then comes 9. And together, they make a number which is the next greater number than the given number using the same set of digits. Talking about the algorithm that we discussed, we started with taking the first half of the string and we were trying to find out the next bigger number for the half. If the result exists, we are returning the palindrome, else we are returning -1. To further break down the step 2, we can put in these many steps. We'll start off with finding the first digit from end, which is not in strict increasing order. We now work in this set of digits. We'll find out the next bigger digit than the first digit, and now we'll make the smallest number out of the remaining digits. And to complete it, we will be merging that number with its mirror image and return it as the next bigger palindrome. Most of the doubts that you might have would have been resolved till now since we are seeing this algorithm, but it will make much more sense when we code this particular approach. I'll highly recommend you to pause this video and code it on your own, and once you are done, you can again come back to this video to see how we are solving it. So now let's jump to the coding part. As we discussed in the first step, we need to take the first half of the string. So we'll first get the length of the string. Since the first half depends on whether the string is of even length or odd length. We have the length. We'll try to find out if there exists a mid digit. The mid digit will only be available when the length is even, otherwise not. The half of the string is nothing but 0 to length by 2. So we have taken out the first half of the string. We need to now get the next bigger number for this half. So we'll pass off this half string as a parameter to this method that we will be implementing. Once we have this particular half, we need to check for certain conditions, like if the bigger number returned is of length greater than 0. If it is 0, we'll simply return -1. This means that the number or the half that we have taken out is the largest number, and there does not exist any number which can be made using the same digits a larger number. Once we have that, we knew that we need to make a mirror image of the half that we have got. So we'll create that. You must be wondering that why we are taking the value into the string builder. It is so because string builder internally provides methods for reversing the string. So we need not to take care of those things. We can simply return at the end the return string, the next bigger string SB. Will append the mid digit and the reverse of the return digit. Now we are done with the basic essence of this particular problem. We have to now move to the next bigger method. So we'll define this particular method. Since we need every digit, we'll convert this particular string into a character array. That is the best way to get the value. Now, these were the steps that we discussed. We need to first find the first digit from the end, which is not in strict increasing order. We now work in this set of digits. Let's say we have a position. We have to start from the end. So it will be charray length minus 1, and let's say the digits that we are looking for, initially it is 0, so because 0 is the smallest number. And now we loop. Since we have already initialized, the position can go up till 0 and the decrement. Over here we need to find out whether the digit that we have is anywhere greater than the current value. So it will be like we have certain value x, y, z, then we have the digit. So the digit, whenever if it is greater than the z, that means z is the first digit that we were looking for, which breaks the pattern of being in the strictly increasing order. So what will be the current value? It will be present at charray position. Now this particular expression will return a character array which is not comparable to an integer value, which is digit. So we'll convert that into an integer by doing a minus of the value of character 0. There is a different way to do this particular thing as well. We'll discuss that at the end of the video. So stay tuned. If we find this particular thing, we need to put this particular charray as the digit that we are looking for, and we will break the loop. Now even if this doesn't match, we still be putting the value into the digit, because when we compare x and digit, and if it is a valid scenario, we need now this digit to be equal to this z, and this is some like m, and the digit variable should move along because we are comparing to the next available digit. So we have found out the first digit from the end, which is not in strict increasing order. The condition of whether the number is the largest number can be deduced by seeing what is the value of position. If the value of pos is -1, that we have went through all the numbers that are present in this particular string, and we haven't found any digit which breaks the condition of strictly increasing order. That means all the values from the end are in strictly increasing order, and that makes the half given to us the largest number that is there. And in this particular case, we need to return an empty string, or in this particular case we can return a string builder. So this becomes the exit condition. If not, then we move on to the next steps to find the next bigger digit than the first digit. Now how can we do that? We haven't stored any of the result or all the digits that we have encountered from the end to reach the first digit. To do so, there are different ways. You can either store them as counts, you can either store them in hash map. For me, since we know that the number of digits are in between 0 to 9 only, I'll be taking a array to store the count of each of those numbers. It will be of size 10, all the values from 0 to 9. Where we will be storing these values? Over here, once we are in this particular loop, we'll increment the count of the position that we have checking with plus plus. For simplicity, let's take that as the current digit. We can put this as this, and we can replace all the usage. Now that we have a count array with all the values that we have encountered till now, till this first digit, we can find out the next bigger digit than the first digit. For that, we have to loop in on the count array, starting from the digits that we already have, which is digit plus 1. We'll loop till 10. If any of those values has a count greater than 0, that means it exists. We'll use this particular value. We'll put this particular value at the position, because position will be the place wherein this particular next higher value should be put. So we'll do all the operations in this if condition itself. We need to remove the count of this val from the counter. since we are using this particular value, we'll put this value in the position and we need to put this value. We cannot directly put that. Similar to what we encountered in line number 58, the current digit in the ch array is a character array. It cannot be directly converted into integer. So for the integer value, we have to negate the ASCII value of character 0. Similar to that, in this particular case, we need to add that value. Once we do that, we have to cast it into a character. There's a good way to do this as well, but that's for the end of the video. Once we have this, we'll increment the position. Since now we are going to the end of the number given to us, we need to create the smallest number, which is the third step. And once we have done this, we'll break this since we only needed one value. Now coming to the part of making the smallest number out of the remaining digits, all the values or the counts present in this particular count array need to be just put into this particular character array, and that will do the job that we are looking for. What we need to do is, we need to start, we'll again take a val, start from 0 till it is less than 10, incrementing it and putting while the count of this val is greater than 0. We simply are doing the same thing over here. We'll just put that. The counter will be decremented. At the position given, the value will be added and the position will be incremented. This can be done in more efficient way with less lines of code, but that will complicate it for now. So we'll keep it this way for now. At the end, what we are doing is we'll just need to return the new string builder. So we have done the coding part. Now let's try to run this for the sample test cases. We encountered an issue wherein it says that it is incompatible types. So over here returns a character and we are putting that into a string. So we convert that into a string. We can convert any character into a string by adding an empty string to it. Now we'll run it again. So this time it runs successfully. We are given the input 35453. We're getting the output as 53435, which is similar to what the expected output is. Now let's submit this problem. So it ran successfully. All the test cases are passed and we are able to dissect the problem. We follow some logical steps to solve this particular problem. The time and space complexity is of n in this particular case, since we are using array to store the half of the string. We can solve this particular problem using constant space as well, but the time complexity will increase in this particular case because we will be using the caret functions more readily. Now coming to the thing that we discussed, how we can convert these current digits by using existing functions provided. We have functions called character dot digit. We pass the array. It also takes a radix, which is 10. You can read about what the radix do and how it can range from 2 till 36, and based on what type of conversion you are doing, it is used. The same thing can be done to convert the integer into a character. We'll use a for digit method. We'll pass the value and pass the radix. Same can be done over here as well. Now let's try to run this code. So it runs successfully. So that is the improvement that we can do, so that it is less confusing in the interviews as well, because the conversion might create new values or give a different value, which is very difficult to debug in an interview. That's all for today's video. I hope you liked it. Do let us know your thoughts, comments and queries in the comment section below. Thanks for watching. See you in the next one.